let's see. The gradient vector. Okay, let's take a look at this. Yesterday, I think it was yesterday we had class, right? Yesterday, you saw this for the first time. Do you remember how first I made you do a directional derivative with a limit? And then I said, hey, we like to get rid of the limits because we don't really like working with them all the time. We'll work with them when we have to. But we did that cool manipulation, that big dense block of text, and we parsed it all out, and then we got this at the end. So if you want to find the directional derivative in the direction u, which has to be what type of vector? Unit vector at the point AB, what do? You find fx, the partial with respect to x, and evaluate it at AB. You do the partial with respect to y at AB, and then you multiply it by the I and j components of the direction you want to go in. It has to be a unit vector. You with me so far? This is what we learned yesterday. This is the sum of the product of two things. This is the sum of the product of two things. We did this a bunch in an earlier section in this chapter. And what do we call that mechanism? When you have the sum of the product of two things, what's another name for that? What's another name for that? Dot product. Adding together the sum of things is a dot product. Do you remember dot products, everybody? Huh? Remember? So if you had a vector like 2, 6, and you dotted it by, I don't know, -3 and 1. If you dot those together, what do? It is a scalar, right? It's a scalar. Cross product is a vector. Dot product is a scalar. What do you end up with? 2 times -3 plus 6 times what? You end up with, in this case, what do you end up with? 0. Ah, great. That is the dot product. What's special about getting a dot product of 0? Therefore, perpendicular. So do you remember dot products, everybody? You with me so far? So here's the thing. Equal signs go both ways. So if you had this product, how could you write it? Ooh, like this, right? So let's go back and look at what's in this pink here. Oh, we have the sum of the product of two things. We can pull it apart and turn it into a dot product. Now that looks notation heavy, right? That looks notation heavy because of the choice they made for how to represent the vectors. They represented the vectors as the sum of the ith component and the jth component. Is there a simpler method to write those vectors? Yeah, you could say fx ab, comma, f what? Fy ab, dot what? U1, comma what? U2. You can just drop, I like writing, I prefer this method. Just fewer things to write. But do you understand the mechanism, how this is a dot product? Are we okay with that math? We're okay with that? So, do you see this vector right here? This vector right here is really cool. That vector in green comes up in a bunch of different places. So what did they do? Gave it a name. Exactly. They gave it a name. The gradient vector of a differentiable function f at a point AB, grad f AB, grad, great, nice. Suddenly they start using multiple letters, is this, fx ab I fy abj. The ith component is the partial with respect to x evaluated at the point, and the jth component is the partial with respect to y evaluated at that point. So you're like, yay, what's so cool about the gradient vector? Why is it important? Yay, Mr. Seamon, why? Well, what were the 3 words from this morning? Oh, come on. Everest.
Cash.
There we go. I worked hard to come up with those 3 words, okay? It's nice that they stuck. Was my messaging clear? Was it good?
Everest, cash,
enlightenment. Yeah, he got it. Yeah, that's good.
I thought it was going to be the Nepal trip. I was like, when's he going to get to what he's talking about?
The way we can restate the directional derivative, instead of having to remember this, we can just call it the gradient of fab dot u. All we're doing is relabeling something we learned yesterday. All we're doing is relabeling something we learned yesterday, and we're pulling this gradient vector out because it's going to be useful later. Just believe me, okay? So if we were to find the gradient, what are the 2 things you need to find to actually calculate the gradient? First, you need to calculate f what? Fx of xy. So in this case, what's fx going to be? What changes, x or y? X is the variable. So what's fxy going to be? 1. What's fy of xy going to be? Come on, speak like humans. Come on. E to the y. And then what do we have to plug in? Well, fx of 1, 1 is definitely still going to be what? Yeah, it doesn't change. It's always 1. What about fy of 1, 1? What's that going to be? E. Exactly. So what did we just find? What is the gradient vector? What's the grad f? Oh, I got to stop saying just g. What's the grad f at 1, 1? What is that vector? 1 comma e. It's just the ith and jth components. Exactly. So now what do we dot that by? Find the grade. Oh, wait, actually, excuse me. It just asked us to find the gradient vector. We're not doing anything with it yet. We're not actually finding the direct. I was just looking for a direction. Do I give you a direction? No. So what is the gradient vector? 1e. That's it. If you're asked for the gradient vector, it's as simple as doing the both partials. Do you have practice finding the partials? Yeah. And then you plug in the point. Yes?
Do you want us to give it like that? But
So let's say I drew this for you. And like this. Okay. Let's say I'm sitting at this point right here. Let's say it goes 10, then 11, then 12, then 13, then 14. If I'm at this point right here, what's the direction of the steepest? Could you draw for me which direction the gradient vector is going to go in? Yeah. How do you draw it? What's the rule if you're going to draw the steepest?
Would it be the one over like the shortest path?
Yes. This is the direction of the shortest path. That is the direction of the gradient vector. That gradient vector is going to be perpendicular to the contour. That's what it's perpendicular to. That's what it's perpendicular to. That's what it means. It's in the direction of the maximum rate of increase of f. Yay, maximum rate of increase. So if you want to search for the steepest paths, guess what you get to do? Go in the direction of the gradient vector. The magnitude of the gradient vector is the maximum rate of change. So if you find the gradient vector, here's what's really cool about it. The direction of the gradient vector is the direction you need to go in, and the magnitude of the gradient vector is the maximum rate of change of f at that point. So now you can be at a point and go in any direction, right? Is it quite likely that the rate of change will be different as you change your direction? Yes. Could you find repetition? Absolutely. But the point is, does it change? Yes. So I could ask you, what direction do you need to go in order to get this, to have the steepest path? You would find the gradient vector. And then I could ask you, what is the rate of change in that direction? What do you find? Of the gradient vector. It's been set up specifically to be about as straightforward as it can be. It's large, and this is what I think someone who said it, it's large when the contours are close together, and it's small when they are far apart. Because when contours are far apart, what does that mean about the steepness? It's less. But when they're closer together, like so when you look at a contour diagram or like a topographical map, and you see on the topographical map something like this, what does this mean? Like, cliff. I've always wondered too how I should look this up because I'm sure there's a standard way, but like there are cliffs that like hang, right? I always wanted to see what do they do for top, like dotted top, you understand what I mean? Like they're gonna overlap and come back, because that happens. Or like how do you do an arch? Like in Arizona, right? You're like, oh. I think on the map it just says arch. You're like, okay, so this is 30x minus 16 over 5x squared minus 4x dx. And then I think some of you tried to do this. U is equal to 5x squared minus what? 4x. So what does du equal? 10x minus 4 dx, right? So dx is equal to... Hold on. I'm saving you some pain. Just listen. Okay. So now you go and do this. What's the problem at this point, though? 10x minus 4 is not a linear combination of the numerator. What do you multiply 10x by to get 30x? 3. What do you multiply negative 4 by to get negative 16? 4. It's a problem. It doesn't cancel, right? So this is what I'd like you to do instead. Shelve this. Keep it up there. This is fine. Freeze this. Instead, start here. Let u equal 5x cubed minus 4x squared. Do that instead for me, okay? Freeze. Instead, do not cancel. And do let u equal that.
I'm just writing.
Ooh, I usually multiply by 2 and bring it to 1 half.
No, I just put the 2 in. Yeah.
Yeah, by the way.
Are these dated with when they were due?
Yeah.
They're not.
It's just, it all corresponds to those.
I understand it corresponds. It's just I now have to look up each of these. Okay, got it. No problem.
Thank you. And there's also a screencast too
Oh,
that I did.
yeah,
That I
yeah.
did. It just hasn't shown up yet.
Okay, I'll do my best.
Alright, thank you.
So right.
We're gonna work on
So we have Alan, you.
Oh, there's gonna be a 1.
After that.
Yay.
Yeah, in you. Yeah.
I'm sorry, wait.
Yeah.
I trust it. Wait, one second. How do you get from here to here? Oh, you are right off.
Let's see.
Okay. Wait, isn't it?
Mean to eavesdrop.
Okay. So
Yeah.
du
I got that.
equals place it for
Okay, when you're done, sit down, please.
Oh.
Looks like you all agree. So, what's my question? My question really isn't, is that the actual answer? I agree with you that your math is correct. Good job. What's my actual question? You guys, super talented. This is algebraically correct, right? Why do you run into a wall on this one? I bring this to you from myself and Mr. Whipple. He brought this to me and he posed this to me. He gave me this one, right? And he asked me how I would solve this one. This is what I would do to solve it. And I've been recording for a long time, so, okay. This is what I would have done. So I was like, okay, so I'm gonna do this. It's 2 times what? 15x minus 8, right? And then at the bottom, people are like, okay, so this is gonna be x times 5x, 5x minus 4, right? Dx, and then I was like, okay, the u substitution doesn't work, so I'm gonna look for 2 times 15x minus 8 over x times 5x minus 4 is equal to a over x plus b over 5x minus 4. What's that called? Partial fraction differential. It's like, oh, okay. And you know what? You can do it with PFDs, right? It's interesting. I was like, oh, I'm confident I can do that. And this was like, oh, okay, that's great. But what about if we don't simplify it and we just do u substitution? My question to you is, what is broken here? Why does canceling that x break the differentiation? And this is totally an extra thing for you to think about. It's not on your homework. I'm going to leave it there for you guys to think about. I don't have an answer for this yet. This is an instance where simplifying brings you to a thing that is much harder to solve. It's kind of interesting.